So with quadratic functions, there's actually quite a lot to talk about. There's quite a bunch of different formulas that you have to understand, and when we're looking to, um, manipulate it and move it on the graph, things change a little bit more. Um, so the first thing that you have to understand is, what does the graph of the quadratic function look like? That's the one that looks like the upwards turned U. So your basic quadratic function is going to also start at the origin here. In fact, most of your parent functions are going to start at the origin, and it only goes upwards. So its domain tends to be all real numbers, but its y values tend to only be positive. Now, when we start taking a look at quadratic functions, it resembles a lot of functions, a lot of other functions a little bit more in the ways that we manipulate it. But when you first start learning about quadratics, you typically start off with the standard form. That's the one at the top here. So at its basis, for a quadratic, you need to see an x squared. X squared is going to be the highest exponent. So again, you may have just an x or x to the first power, but you definitely always have to have an x squared. Nothing higher, or also becomes some other type of function. So the first form here, this is the standard formula. And honestly, when it comes to the graphs, it's not that useful. The standard formula is useful in that it can help us get to some of the other formulas and figure out some other bits of information. So you typically start learning off this because you start learning how to factor. And we're not going to get into the nitty gritty of how to factor, but basically the standard function helps us get to the second one on this list, which is the factored form. The factored form helps us figure out basically our x-intercepts. So you should know that a factor, those are the ones that look like, say, x minus 3, x plus 2. And one thing that you have to remember in your classes is that factors are not the same thing as solutions. We use the factors in order to get our solutions, but keep in mind that they're two different things. So if a question asks for factors, we're looking for the forms where it's in parentheses with the x or whatever your variable is. If we're looking for a solution, we then need to take that factor and equal it to 0. And then you're going to solve the equation that you created for each of these. So plus 3 on both sides, minus 2 on both sides there. So we would get x is equal to 3, and x is equal to negative 2. Don't confuse this with always just flipping the sign, because if you have a more complicated factor, for example, if anything were put in front of the x's here, that's totally going to change your equation. So don't form a bad habit just by thinking that you only flip the sign. That's great for these simple factors, but that's not the only thing that always happens. So just be aware of that. So our factors here, if they're x equals 3 and x equals negative 2, what that means is that we have a particular quadratic that forms that passes through the 3 and passes through the negative 2. We would want to find a little bit more information, such as what the vertex looks like. Let's just say for now that the vertex is down here, and then we could draw a new point through all of that. So basically what this allows us to figure out is that it allows us to plot those main points where it is passing through the x-axis, but we would still need a little bit more information to really help us out in drawing it out. Keep in mind that just like with what I mentioned with linear equations, that every point on the line is a given solution for it. So just like we have coordinates for linear functions, we have coordinates for all of our quadratic functions. And if a particular point, let's say here, this looks like 2 comma 5. So that means that if I had the proper graph for, or the proper function for my quadratic here, that means that I should be able to put in 5 for my y value, and I should be able to put in 2 for my x values, and so on. And then things should equal out if everything said and done was proper here. But again, we're not going to assume that my graph here is accurate because it is not. But just some of the main things that you should watch out for. So we talked about the two formulas that you start off by learning. Standard formula, which really is just useful for giving you the position of the graph. Remember, your a value not only tells you if it points up or down. A positive a means it is positive. A negative a means that it is negative and pointing downwards. And then if your a is a number bigger than 1 or bigger or less than -1, it's going to shrink. So for example, 3x squared is going to give us a skinnier graph. And then if it's a number in between 0 and 1 or 0 and -1, like 1/2 x squared, it's going to get a little wider as a result. Those are the key things that you should know about that first graph. And then there's also a formula that we can use to figure out the vertex. That formula is -b over 2a. So when we use this formula, we're referring to the a and b that are written right there. So if I had a particular quadratic that, let's say, was y equals 3x squared minus 2x plus 1, then I could say negative 2. Keep in mind that my 2 here, it was a -2, and just because the formula says a negative doesn't mean that I can assume that that's the same negative. The negative in the formula means that whatever my sign was, whether it was positive or negative, is going to flip. So I put -2, and then 2 times my 3, which was a. So this would end up giving me, looks like, +2 over 6, which simplifies to 1/3. I could take this 1/3 here, which is my x value for my vertex, and I could plug it back into this particular formula. So if my x is 1/3, that means I could do 3 times 1/3 squared minus 2 times 1/3 plus 1. So 1/3 squared is 1/9 times 3 minus 2 over 3 plus 1. Let's actually clear up some space here so we can see what we're doing. So I'm going to rewrite this, continuing on the left side. So we have 3 times 1/3 squared minus 2 times 1/3 plus 1, because we plug things in there. Like I said, 1/3 squared is 1/9 minus 2 times 1/3 is -2 over 3 plus the 1. That's 3/9. We're going to just simplify that to 1/3, and minus 2/3, then plus 1. So 1/3 minus 2/3, that's -1/3. And then plus 1 here gives us +2/3. So that would mean that the vertex for this particular graph would end up being at 1/3 and comma 2/3. And that's how we would figure that out. So a little bit of math that we have to do, and sorry, I made this probably a little bit messy, but the basics is we would use that formula, negative b over 2a. We plug in our functions, or the numbers that we have from the standard form, and then that's going to give you the x value for your vertex. Once we got the x value, which in this case was the 1/3, we plugged it back into the original formula, and that gave me my y value, which was 2/3. So that means the solution for the vertex for that particular line I drew was 1/3 comma 2/3 in this case. That's all the information that we can basically use out of the standard formula. And so when we're moving on to the last formula, which is the vertex form, now the vertex form is really useful because it actually gives us our vertex. So you'll notice that with a lot of other functions going on from here, you're going to see h and k. The h and k are stand-ins for your x and y. Keep in mind that anytime you're given coordinates, whether it is h and k, whether it's some funky shape or something like a triangle and a circle or anything else, if they make it look like a coordinate, then assume that it's the same coordinates for x and y's. So they're just substitutes. The reason why the h and k exist is because there's already an x and y in this, and so they stand for two different things. The h and the k specifically stand for the vertex of our quadratic formula here, and for the x and the y, those are your standard any other x and y coordinate that are not the vertex in the quadratic function. So for example, I could have a line that looks like y equals 2 x minus 3 squared plus 1. Keep in mind that the h in our formula, just like I was mentioning with the last formula we used to find the vertex with the negative b, this is a minus h as well. So we sort of should assume that the h is going to actually be the opposite of what we see in this formula here. So that means that my vertex for this particular quadratic would be a positive 3 and a positive 1. The k is positive in the formula, so we don't really touch that. But just beware about this h there. But that's the most helpful thing that the vertex form helps us get. Of course, it gives us our a. So in this case, we have a little bit of a stretch, and it's positive, so it's opening upwards. And then other information that we can gain from this is basically we can change this into some of the other formats. So for example, I could take this and expand it, such as 2 times x minus 3 times x minus 3 plus 1. And if I were to do all the math here, then it would end up giving me the standard form for this particular quadratic. So these aren't factors per se, because it's a little bit different because we don't have the full standard form here. Just keep in mind that we use this for the vertex. But I could distribute here, so that would give me 2x minus 6. Then we're multiplying times the x minus 3. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. Minus 6 times x, another minus 6. And minus minus 6 times minus 3 is positive 18 plus 1. So the full standard form seems to look like 2x squared minus 12x plus 19. Usually we wouldn't have to do all of that information unless you're just learning about that characteristics. What's more useful to you later on is to figure out what the vertex formula means in terms of transforming the quadratic. So let's use the same exact equation that I used here. Let's rewrite this and make it easier to see. So remember that the h is our x value and the k is our y value, and that changes our vertex. But think about that for a second. If I change the vertex, that means I basically have to shift the entire function because the function kind of pivots around the vertex. So another thing that this kind of format shows us is the transformations of the graph. So your h, or the value that comes in your h, that's going to show us our horizontal transformation, and the value for the k, that shows us our vertical transformation. So keep in mind that the h is still negative, so it's the opposite of what we're seeing. But so we have a minus 3. That means that we had a positive transformation over by 3. And then we had a positive transformation up by 1. So our new vertex would be shifted to 3, 1. And the new quadratic would go through it and look like this. So I'll point this out with all the other functions as well, but for this format, we can see that the vertex shifted over, so it shifts over the entire function as a result too. Let's clean up by talking about just the other bits of information that we need to know. So again, the standard form, or your standard parent function, it's going to have a y intercept that passes through 0, 0. That's where the origin is going to be. If we shift that h or that k, that's going to shift our entire function over, but that's another thing. So when we take a look at it, domain, as I mentioned up top, our domain is going to be all real numbers, or again, negative infinity to positive infinity, because it hits all of the x values if we were to draw that. And keep in mind that it keeps going forever. Same thing with our range. Now our range, notice that there's nothing at the bottom of this graph. So with quadratics, they typically have a more limited range. The typical parent function for the quadratic is going to start off at 0, and then it goes up to positive infinity. If it were a negative, then it would be the opposite. It would start from negative infinity and go all the way up to 0 as the limit. Keep in mind that we always do this in terms from smallest number to largest number. So for the negative graph, the 0 would be, of course, the maximum for the largest number. That's another term that we have here. When our vertex is at the bottom of the quadratic, we call that the minimum. And if it was negative, then the vertex here would be called a maximum. End behavior. So as our x is approaching infinity, so as we go up in our x values, our y values seem to also go up. Now, the other kicker though, as the x approaches negative infinity, what is happening to the y? Well, it goes down for a bit, but it continues on the other end to then go back and go back up. So for your quadratics, as the x approaches negative infinity, your y is actually going to approach positive infinity because it keeps going back up no matter which way you look at it from the x sides. So that's basically everything that we need to know about quadratic functions, how to manipulate them, how to graph them, the main characteristics and all. Next, let's talk about the next function. So that's basically everything that we need to know about quadratic functions, how to manipulate them, how to change them, the key formulas. Now let's go on to the next function.